My name is Kir, and my talk today will be about monolithic Rails apps and just large apps in general, not from the perspective of how many requests per minute you can serve from your app, but from the perspective of developer experience and developer happiness and developer tools. I work at the team which is called Developer Exploration. I'm going to describe more about what our team does. I live in Canada, that's where Shopify is based. I'm from Russia originally. That's me with my friend's cat. Because I cannot have a cat because my landlord is cat allergic. A bit about Shopify if you don't know what we do. We are an e-commerce platform. You can register online and open your own online store in just 5 minutes. So you wouldn't need to manage and host your own online shop scripts. You can also sell in different channels, like you can sell on Facebook or with POS terminal that you can use with iPhone and sell offline. And we're known as one of the largest and oldest Rails apps in the Rails community, which means we're a monolith. I would say that monolith is not good or bad. It's just an approach that you can take when your business is growing. And you get some problems with monoliths, as well as you get problems with microservices. But you still have to solve some problems in both ways. And today I'm going to talk about the monolith problems. To have some perspective on how much code we have, that's a million lines of code and hundreds of models and controllers. And I would say that the vanilla Rails doesn't really handle that. Because if you imagine when you just start your Rails app, type Rails new, that app feels very, very light. It starts in just 2 or 3 seconds. And but it's not going to work when it needs to load 300 gems and deploy to 500 servers at the same time. So that's kind of the problems that monolith has to solve. And the team I work is called Developer Exploration, and this is the special team that solves all these problems, works on developer tools, because we have hundreds of developers too, and we need to make them happy, so they wouldn't struggle with slow tools and slow development, and that they could ship their code and iterate faster and deploy business features. If we think about it as a platform, it's the Ruby language in the bottom, then comes Rails as a framework, and on top of the Rails framework are our developer tools that include continuous integration to run many tasks efficiently and tools to allow hundreds of people to deploy the same application at the same time. And I'm going to describe all these tools. So imagine if it's your first day at the job, and you were handed a laptop, and you were added to a GitHub repo, and now you're supposed to clone the repo, install the databases that the application is using, install all the gems, install the Ruby version that the project is using. At some point, when you do bundle install, the Nokia will break. Then you go to Stack Overflow and just copy-paste the first or second tip. We have many developers joining the company every week or every month, and we cannot afford making all these developers to copy-paste comments like brew install or comments to fix Nokia. So we had to come up with a way to make it just one command for everyone. And the first thing that you'll think about is a virtual machine. You can use Vagrant, distribute the same virtual machine over all developers. They will have the same environment that will be consistent, and they won't need to copy-paste and run many commands to prepare the environment. So we tried Vagrant, and it didn't work really well. Because on the first Vagrant run, you need to create the virtual machine. And then because we try to make our Vagrant VM as closest as possible to the production, you need to apply the same things that were recently applied to production. So you need to update that VM every maybe week. And then for some kind of development, VirtualBox makes it slower, and it doesn't support all the things that you can do locally. For example, if you need to watch the file changes, VirtualBox file system drivers may not support watching and stuff like that. We tried replacing VirtualBox with other VM drivers like VMware. It got a bit faster, but it wasn't still the best thing, and many developers complained. We do a survey of our developers, like what are the things that you struggle with when you develop every day, and at some point the local development with Vagrant was the first thing that developers hated. So we had to redesign how we do the local development from the scratch because it didn't work with Vagrant. And while we were looking for the solutions, we found this native virtualization framework called Xhyve. It's internal macOS framework, and it works really well and really fast, super reliable. If you ever used Docker for Mac, Docker for Mac is using Xhyve under the hood. And we built our small Mac app that launches Xhyve virtual machines for every app. And as you can see, for our main app, we have like 10 services that the app needs. Some services you know, like MySQL and Nginx, Redis. Some of those are internal. We kind of solved the virtual machine problem because now we had VMs that start really fast and that are reliable. You don't need to update them from production cookbooks. But the local development problem wasn't solved yet. Because for the local development, you still need to install Homebrew packages, install the language that the project requires. It can be multiple languages. If you have Ruby app that is using some JavaScript, you need to install Node. Also need to create the database to run the test and to develop locally. So we thought about what if we can describe what an application needs in some meta file and then apply that. And ideally, it would be just one command. So we have this script called dev. You run dev up, like Vagrant up. And we got this YAML that describes all the components that a project needs. Because we use this all these scripts and infrastructure for many projects, because beside of the monolith app, we have some smaller apps. So now all apps in the company have a YAML file that describes what services the app needs. You just type one command when you start working on the app, and your local environment is just ready. Because it knows that it has to install Homebrew package and a specific Ruby version, prepare the database. So your first day at the work, you installed the development environment. Now it's time to write some code and maybe push it to GitHub. And the next thing after pushing code to GitHub and sharing it with your colleagues is probably that your colleagues will start reviewing your code and giving your feedback. And in a smaller team, It's easy because you have one or two lead developers, and they will express their thoughts on maybe some dangerous things that you're doing in your code that you shouldn't do. And you have this one person who keeps in mind all the dangerous things that you can do. In our case, we have hundreds of lead developers. Some of them have contexts in client-side development. Some of them had contexts only in mobile development. And we need to somehow watch that people do not introduce any Ruby, any vulnerabilities or dangerous things in Ruby that they can introduce. Because we also have interns and developers who just started working with Rails. And some dangerous patterns that we would like to detect are, for instance, we have a lot of gems and a lot of dependencies, and we don't really want this list to grow. So every time someone adds a new gem, we want them to consider if they really need this gem, or at least check if this gem is maintained, or if it has some security vulnerabilities, which is also important. And then we don't want developers to change existing migrations, because that's just not how things work, right? Instead of changing migration, you would add a new one and run that. And we also don't want developers to just change the application config just for their feature, because it's going to be a mess. And we have this small bot that watches new pull requests on GitHub, and with regular expressions and some other magic techniques, checks what sections of the application you touched. And in this case, someone introduced a new JavaScript library. It pings the right people who watch JavaScript libraries and who watch the asset pipeline. And especially watch the fact that asset pipeline doesn't become slower. Now, when your code is reviewed by bots and humans, it's now time to run the tests on CI. And in case of a smaller Rails app, it's also easy because you have maybe hundreds or maybe thousands of tests. They would maybe take 5 minutes to run, which is pretty affordable. When you start to grow above that number, you can parallelize your tests, run them in 4 processes, and make this automatically 4 times faster, and be happy because your CI is now super fast. And we went the same way as you probably. Oh, can you raise a hand if you parallelize the tests? Cool. That's pretty awesome. And we went the same way as you did. We parallelized them, but it wasn't enough because we have around 50,000 tests. It was, I checked that a couple of months before, so I think now it's even bigger. And we need to think about what are the limitations of how many parallelized processes of tests you can run. And you will not believe me, but it's almost 200 parallelized tests. And they work as a job queue. You push all tests into a queue, and then you spin all these workers in cloud, in AWS, and they take a new test to run it. And because this is a job queue, and workers get their own job, we can ensure that all these tests are equally distributed between different workers. This is how it looks like if one test in one queue failed. And what is awesome about it is that we can run 50,000 tests in just 6 minutes. And if we wouldn't run that, it would take maybe weeks to run 50,000 tests in the same thing. Yeah, so as you can see, developers run only specific tests on their machines, and they heavily rely on CI. And that's why we have a special team who just works on CI. Now, when your tests are green for your pull request, you're probably going to merge it and deploy. And small team, It's also easy because you probably have one person who is responsible for deploys, and they will deploy it once or a couple times a day and see if we introduce any big changes, any big commits, and watch carefully. It also stopped working at our scale at some point because we got too many developers and too many changes. And we started to think how we can design this process in a way that all 300 of developers can deploy the same app when they need. And the idea is that you as a developer are responsible for shipping your own changes and watching that these changes do not break anything. So right after merging the pull request, every developer gets a message from another bot in Slack, like, hey, we're going to deploy your commit soon. Please go to this link, monitor and watch how the production goes. And if the error rate goes to 1,000 errors per second right after your commit, probably you did something wrong. And we provide people with a very easy and quick way to roll back the changes. So they can roll back and revert the commit and let next people deploy. This works pretty well. And people do not introduce any breaking changes, any changes that break production really often, maybe once or two times a month. And I think it's really great that we can allow all these developers to ship their changes, and they will feel responsible for it and watch it closely. There is also another thing that imagine that right now you're investigating some issues, and you don't want people to deploy new stuff, and especially to merge new stuff into master, because it will get confusing while you try to investigate the issues. And we wanted a way to stop people from merging new things. GitHub doesn't really have that feature, so we wrote it ourselves. We have a small service that can tell you if you're allowed to merge or not. And this Chrome extension adds a big alert on GitHub merge button if we do not want you to merge any new stuff. And that also works pretty well. So people know if we're investigating something and we cannot deploy at this moment, please do not merge. Now I have some list of the things that you may face when your app is getting bigger and larger, and it should be really useful to know about our experience. For instance, Rails upgrade. It's very important that your app is running the latest Rails, especially if you're a monolith, because people will just because developers are not going to work for you if you have a monolith that is super slow to boot and that is using Rails 3 and all the kind of struggling experience. So we want to provide developers with the best experience, and now we're running on the latest Rails. It took us a really long time to upgrade, and we got some tricks that we learned during the upgrade. And so the idea is that for a smaller app, you can upgrade Rails in a separate branch and merge that branch when it's ready. And in our case, people update master many times a day. So any branch that you would make with a Rails upgrade that touches many files would become outdated in a couple of days. So we had to upgrade Rails right in master. And that means that our code in master should be able to run both Rails versions, in our case 4.2 and 5.0. That was quite challenging. What we did is that we prepared all the gems to be compatible with Rails 5. And then we set up dual gem files. Let me show how it looks. So depending on the env variable, the app was using one Rails version or another, and the same one for gems. the gem you see action pack XML parser, like we had to use a different version for Rails 5. And that really helped us to have this kind of conditional gem file. And the same thing applied to code. Sometimes we use different code paths and conditions depending on the Rails version. Here are some examples. For instance, Rails moved some internal constant into different location. So we had to be compatible with that. And then we fixed all tests that were failing in Rails 5. And what's even more important on that step, on the second step, that will, as well as, so we run CI that checks, that runs the tests on both Rails versions. And developers could be sure that their code works on both versions. And at some point, we had these two CI statuses that shows you that your code doesn't pass on Rails 5, and it does pass on Rails 4. So you could see the failure on Rails 5 and fix the issue. And then at some point, we were running both Rails versions in production because it's too dangerous to launch completely new Rails to all customers. And we have a special deployment pipeline that allows us to deploy one version of Rails to just 10% of the customer, see if there are any issues, if there are any new exceptions, or if people report that some features are broken, then we could roll back to 0% of new Rails, fix the things, and then start rolling out from 10% to 100. And you can imagine how happy we were when we could roll back it to 100 and see that nothing breaks. Another important thing that I mentioned is the application boot. If imagine as a developer, you boot your Rails application maybe a dozen times a day, and I measured that for just new Rails app, it takes less than 3 seconds to boot. And you probably experienced that as your app is growing and as more gems you have, the slower the app takes to boot. We had to address that as well, because now we have so many gems. And one of the reasons that becomes so slow is that when you have many gems, you have many requires. And every time you require something, Ruby goes through all the gems. For instance, you require active record, and Ruby goes all the gems that you have available and checks if some gem has activerecord.rb. If it has, then it's using that file. So every time you require active record, Ruby converts that path from just active record to the full path. And that works very fast if you have only 10 gems. And imagine how slow it becomes when you have 300 gems, because for every require, you have to iterate. This is what we call the linear growth of every require call to the number of gems. So we wrote a small library that caches that lookup, and it saves a very huge percentage of the boot time. I would say that without it, our app would take maybe 20 seconds to boot, and with this optimization, we could optimize it to less than 10. And this is a very low-hanging fruit that you can use. So we try to open source all the performance things that we do. Sometimes these are Rails patches that go directly to Rails upstream, so we can make Rails faster for everyone. In this case, this is a gem. I will have a gist with all the links that I mentioned in my talk. But yeah, this gem is called Bootscale. And then we need to keep developers in a sandbox, because there are so many things that you can do in Rails that would break something in the future, and we don't want them to break it. Some of the things are called shitless. This term was invented by one of our developers. And shitlist works as, imagine you have some legacy class that many other classes are using, and in the future, you would like to remove that legacy class. So you allow only specific classes, you're allowed to use that legacy class only in 10 specific places. And in this case, no new developers will introduce usage of that legacy class anymore, because you allow to use that class only in 10 particular places that you're going to fix soon. You'll get a link to more details about stateless. Another important thing is that imagine you save a model called picture, and it has a picture attached. And how it works usually is that the model would upload picture to some storage like S3. That's probably how you do, and how all of us do that. So there is some storage. And it may take a few seconds to upload picture to that storage. And if we do that from inside the database transaction becomes 3 seconds slower. And imagine if the connection to S3, there are some troubles with connections between different regions, and that upload takes 20 seconds, meaning that a lot of database transactions will take 20 seconds, which is really bad if you have a large app. So we have to do things like not allowing people to do external HTTP calls from inside transaction, because that's really harmful. And then we linked database migrations so that you wouldn't introduce a migration that would take weeks to run. And also some things about resiliency. Like we want our app to be able to boot and start and serve requests, even if MySQL and Redis are down. And in some cases, we make developers write code in terms of what would the result of your operation would be if MySQL is down. If it's some product page on the shop, it's usually like this product is not available, because this is better than showing error 500, right? So to summarize, we do continuous improvements of the deploy and CI flow. And what I really like about what our team does is that we make life of all our developers happy. And they were so happy when we introduced new VMs instead of Vagrant, because they didn't like Vagrant, and it was a very bad experience. And they also become happier when we make our CI faster, because they can iterate faster. And we also really like to share our tools, like that thing that improves require or performance patches into Rails. So you can talk to me if you're more interested about what we're working on. Here is my Twitter handle. If you go there, there will be a gist with all links to the thing I mentioned. It should have posted by now. Thank you so much.